Okay, thank you, Margot. Thank you for coming, all of you. This is probably the most important slide of the talk, actually. It's only 15 minutes, so this is just an introduction. Some of you have met me before at some of the other ICME events, so I'm Ramesh. All 6 of us are faculty in management science and engineering here, which is right down the hall, actually, but also very closely affiliated with ICME. The reason it's the most important slide is really the point of bringing the 6 of us together was to have research activity that was focused at the interface between computational science and mathematical methods and social and economic problems. So all of us have this sort of hallmark in our own work. Itai Ashlagi is a market designer. He's well known for having had significant impact on how kidney exchanges have run, as well as the Boston school choice mechanism. Ashish is a professor in management science and engineering who's made significant contributions to, among other things, recently crowdsourced democracy, participatory democracy. So he has a platform that helps budgetary decisions get made in distributed democratic environments. And in particular, this is something that's been tested out in a couple of precincts around the country. Sharad Goel is someone with an applied mathematical and computer scientific training who now works quite a bit on the social science of large-scale social networks. You'll hear a little bit more about what I do. Amin is a computer scientist who, among other things, recently took a leave from Stanford about a year plus to start a company that runs a large online education platform. And this in particular was a unique one because it was very focused on team learning, on social, sort of the social aspect of education, which, of course, many of you probably can guess, online is a hard thing to deliver. And then Johan is joining us in the fall, and his expertise is in network experimentation, in particular, running experiments where the individuals in the A/B test are actually individuals that are connected through a social network. So you'll hear a bit more about this as I go along. In terms of where the lab sits, I think this is really what brought all of us together. It's that on one side, we've seen amazing advances in technology and algorithms. And all of us, the 6 of us that I described on the previous slide, have all been very close to these advances in one way or another. For example, my own background was in communication networking. Ashish and Amin have worked quite a bit on network algorithms. So this is something that all of us were coming from. And I guess speaking just personally, to give you sort of personal viewpoint on this, one of the things that I noticed was happening, I've been at Stanford since 2004, and one thing I've noticed was happening in my career was that I would train students in the classroom that would then go get jobs where they were basically asked to engineer social platforms or economic platforms. And the kinds of things that they were asked to do were typically to code up algorithms for, let's say, large-scale collaborative filtering or algorithms for matching on a large scale. But I think what was really important was that in the end, the system they were impacting was a system with human users. And that was really not necessarily something they were well trained to handle. And that's really where you transition over to the other side, which is all this technology that they were building, what was it really doing? It was changing the way humanity was interacting. That's really what it's in service of. So on one side, the technology is enabling these new platforms. On the other side, oh, well, that doesn't look good, but in any case, that should say data. On the other side, all these interactions are generating lots of data that's, I think, then feeding back in to changing the platforms themselves. Okay, so a good example of this is, if you're able to build a really efficient distributed data center, it makes it possible to run a large-scale online social network. But that online social network generates huge amounts of data about who's connected to who. And in turn, that data allows us to develop all kinds of new applications on top of the social network that we couldn't develop before. Okay? And so that's a loop which we've seen play out over and over again: social networks, recommendation systems, online marketplaces, online education. These are all examples where this loop between algorithms and technology on one side and data generated by social and economic interactions on the other is playing out over and over again. And so our lab basically lives at this interface, combining computer science, algorithms, and data, which is really sort of the hallmark of our own training, with social science and economics, which is, I would say, where all of us have moved over time. High-level problem areas that our lab is focused on: social network analysis is a very big one. I think this includes both computational methods for social network analysis, which, of course, I think either between the posters that you've looked at today or some of the talks, you'll certainly understand that in thinking about applications of large-scale numerical linear algebra or those types of methods, social networks are a prime application because essentially you encode the network as a matrix. So there's all kinds of interesting computational work around social network analysis, but also social scientific work around social network analysis. So there's very basic questions about, for example, what can I identify about you just by knowing about who you're connected to, right? So this is really a social science question, but it's something which is resolved algorithmically. Social media strategy is another big one that, in particular in conversations with industrial partners, comes up quite a bit. This is related to topics like virality. Trust, reputation, and privacy is something which is, I think, increasingly on everyone's minds. I think one thing I want to call out here that I'm very focused on lately is reputation in online marketplaces. I think that it's an underpinning of how all online markets work is that you're able to trust a transaction partner that you'll never meet. And reputation to me is, again, one of these fascinating points where computation and algorithms are meeting social science and economics, because reputation on one side is a very algorithmic problem. It's a question of taking individual pieces of data that are generated on billions of transactions and producing a succinct summary of what you think of somebody. At the same time, it's a very important social science problem, because ultimately what you're trying to do is to deliver trust to a transaction partner on the other side, and that's not something which is just an algorithmic question. Market design, matching, and pricing is something I've been involved quite a bit, as well as ETI, as I just mentioned a few minutes ago. Incentives, I mean that more generally beyond just trust, reputation, and market design. What I mean by incentives is I think there's a philosophy underlying the lab that's important to understand, which is despite the fact that we're all algorithmicists in training, we don't necessarily take an algorithmic viewpoint to solving every problem. And I think there are many problems where, as a data scientist, your gut reaction is to solve the problem by building an algorithm that predicts what the user would have wanted, when it would have been easier to just ask them what they wanted. And I think that's really what I mean by incentives, is that one of the ways that our lab is interesting is that it brings together an economic viewpoint of eliciting what someone wants with an algorithmic viewpoint of understanding what they want. And that's, again, a very important balance in almost every product design in the technology sort of space that we're focused on today. Group decision-making and consensus problems, this goes back to the participatory democracy work that Ashish has been doing. And then crowdsourcing and distributed work is another big area of emphasis for us. So in the lab, I think the reason in particular I'm kind of excited to talk about this here is just that for us, the types of problems we're working on are messy by nature. They're sort of driven by social and economic realities. And so, at the same time, all of us are kind of mathematical modelers and computational experts by training. What we want to do is fundamental research, but that ultimately is having high practical impact. So we accomplish this, through our lab itself is a group of, I guess I left faculty out of that. That's an important part of that group. But there's a vibrant research group of faculty, PhD students, and postdocs. I think I emphasize the most important people. We're only as good as our PhD students and postdocs are. We have a highly visible seminar series that we run that actually anyone is welcome to attend called Research on Algorithms, Incentives, and Networks. This is really an amazing seminar. It began a long time ago as the group meeting of Rajiv Motwani. And some of you who may know Rajiv, he was a very prominent computer scientist at Stanford who passed away suddenly several years ago. And this is sort of inherited from him by Amin and Ashish and a few others on campus. And today, I think it's really blossomed into something which is a cornerstone of bringing together many people on campus with interests in this area. So we often have economists and social scientists coming to both speak in and be in the audience of this seminar. And finally, the reason I'm here is, in part, these strong and diverse industrial relationships. So this is cut off at the bottom. I think this must be a font issue. So what this did say is that Stanford students can make transformative breakthroughs if they're pointed in the right direction, if they're given the right problem formulation. And what I mean by that, that's a really important point, which is that one of the reasons these industrial relationships are so important to us and that practical impact is so important is we don't know what problems are essential. Yeah, we don't know which problems are essential. So we use our relationships with industry to help point us in the right direction. And that really is a two-way street because, in part by doing that, we're able to then also impact industrial problems. So I don't have enough time to walk through all these in great detail. I'm happy to send the slides to anyone who's interested. But just to give you some high-level examples of things that our lab has worked on, there's been a lot of work on recommendations and collaborative filtering. Ashish did a sabbatical at Twitter a while back, and then since then had worked with them quite a bit closely afterwards. So for example, he helped develop the who to follow mechanism at Twitter using graph-based methods. They've also recently made significant advances in his group on personalized PageRank and speeding up personalized PageRank. What's interesting about this was that the inspiration for the algorithm they used here came from the fundamental observation that human beings have a fixed amount of attention. If you build that attention budget into the algorithm, then you get some sort of interesting observations about how to design a better algorithm. I've worked a lot on recommendations and matching in online markets. And sort of one interesting observation that we made from our work was that in these markets, usually the thing you think is that online markets are good because they reduce frictions. But one interesting problem with that is that they can actually go too far. And there are cases where if you actually thin the market out, make it harder for people to find each other, you can improve market outcomes overall. And I'll close with this example, which is, I think, a huge area of emphasis for us today across several of us, which is, I think that technology, one of the things that it's changed is just how we learn about social and economic systems. We have much lower barriers to designing and running experiments and doing so at large scale. And so our group as a whole, Johan, Sharad, myself, and Itai in particular, are really focused on thinking about this interplay between information technology and social science from an experimental standpoint. So understanding how experiments teach us about social systems, and also thinking about how you design and sort of build platforms for better experimentation. So for example, Johan has been heavily involved in designing computational platforms for experimental design in networked environments. I've been heavily involved in thinking quite a bit about user interfaces to statistical analysis that are used in A/B testing in practice. And then Sharad has done quite a bit of work on inference on large data sets. So let me stop there. Anyone who has more questions, obviously, you're more than welcome to email me or ask me about it later at the reception. Thank you.